Yo, what's up guys? It's your brother G Money Wisdom coming back at you with another video, and today will be part 4 of Kaspa, what it is and how it works. So let's pick up where we left off in part 3. In part 3, I was talking about how I would define a node and a hash, because while explaining how Kaspa uses a proof of work, I had to use the words hash and node, and if you guys don't understand what that means, you're gonna have a hard time kind of understanding how that works. So anytime I drop like a word like that, especially that I didn't know when I was researching, I make sure to include it, because if I didn't know it, there's a good chance you guys may not know it as well. And I'm just trying to be as helpful as possible to kind of explain all this stuff, because this stuff can be pretty confusing at times if you don't have the definitions or the nomenclature, meaning like the definition of the words being used or phrases. So what is a node? Very briefly and very simply, a node is a computer that is connected to a blockchain network. Each node keeps a complete copy of the blockchain, ensuring that the network's history is decentralized and cannot be tampered with. Nodes basically contribute to the decentralization and security of the crypto network. So basically what a node is that it's just a bunch of computers connected to a blockchain network, like globally, or in some sort of like warehouse or ecosystem, stuff like that. A hash is a unique fixed link digital fingerprint that represents a specific piece of data. A hash basically ensures data integrity and security. So with those two things defined, let's move on to the Phantom protocol, and then very briefly I'll go over what a layer 1 is, because in the beginning when I described what Kaspa is, that it's an open source decentralized proof of work and scalable level 1, I meant to say layer 1. So we're also going to go over what a layer 1 is. So first, however, let's go over the Phantom protocol. The Phantom protocol is also made up of a couple of components that I will go over and define for you guys. So the first component is an asynchronous proof of work. And basically what that means is that a mechanism allows miners to create blocks asynchronously, meaning miners can create blocks without waiting for the previous block to be finished. Unlike traditional blockchains, like every other blockchain, you have to wait for these blocks to be verified before you can create the next one, which makes it secure but also slower. So Kaspa has found a way to do this while also being secure. So not only is it secure, but faster. So where was I? This helps improve scalability and reduce latency or slowdown/lag. Parallel block creation. Miners can work on multiple blocks at the same time, increasing the overall productivity and throughput. Throughput meaning amount of data passing through a system. GhostDAG integration. The Phantom protocol is tightly integrated or connected to the GhostDAG system, ensuring that the longest valid chain or chain that has done the most work is selected, even with parallel block creation. GhostDAG ensures that the valid chain of blocks is selected, while the Phantom protocol allows for efficient block/parallel block creation. So this is pretty innovative stuff, guys, and which is why I'm really bullish on Kaspa, and I see Kaspa becoming huge and possibly even adopted by the masses in the future. Just because of the technology, the more you learn about Kaspa, the more you're just blown away. So let's go over some more things about Kaspa. Kaspa is an instant transaction confirmation, or has instant transaction confirmation. The block time is 1 second. This improves user and developer experience. Transaction costs are also lowered, around 0.0001. So compared with like gas fees of Ethereum, which can be like $4, $3, $6, this is 0.0001, which is a fraction of a penny, which is extremely cheap. Anybody could afford that. Time between blocks is greater than the time for a chain to learn about a new block, making Kaspa secure. GhostDAG was created to resolve the security trade-off between scalability, speed, and security. Kaspa utilizes a DAG, or directed acyclic graph, where a block points to several blocks instead of one, as opposed to most crypto projects. Transactions that line up with earlier transactions are integrated into the DAG, which is set up as a crisscross chain. So I don't know if you guys can see this illustration, because my camera isn't really that zoomed in and I can't really zoom it in since I'm using an iPhone, but we're working with what we got. This is basically the representation of the DAG. So this is a block, right? And then this is a traditional blockchain with just a bunch of blocks going in a horizontal manner. With a DAG, think of it as like a web, like a spider's web. You can have this central block right here, but it can also go off into other places in space. So not only is the blockchain not horizontal, but it's more like spread out all over the place, because with the parallel block creation in the Phantom protocol, you don't need to wait for this block to be verified to create all these other blocks in these other directions, where there's just a bunch of different blocks being created at the same time, versus this traditional blockchain where you have to wait for this block to be verified to create this one. And then you also have transactions being verified at the same time as well, which is pretty insane. So the video is reaching around 6 minutes now, so I'm gonna do the final part of Kaspa, and I hope this has made sense so far. We'll go over the trilemma, how Kaspa addresses it, and if Kaspa prioritizes scalability and decentralization, how does it achieve security? So I'll see you guys in the next video.